Welcome to this video. Students, in this video we are going to solve a problem of homogeneous differential equation of the standard book M.D. Raisinghania of section 2.8 and exercise 4. So without wasting the time, let's begin the journey. What it is saying? This one, right? And students, many of you will be confused that what are these two equations, right? And you may be confused that what we have to solve. So students, see, for your kind information I am saying that, see, this is nothing but just the simplification of it, right? So at first I will show you that how this expression is coming from this equation. After that we will solve this one, right? So see, at first we have to write, so write that given that what is given, x cos y by x into y dx plus x dy minus y sin y by x into x dy minus y dx, right? So this is my given equation. Okay, sorry student, this is actually equal to, right? Now see, what can we do now? So just do the simplification as usual. Okay, so see, if you multiply this term with this term, then what will we get? We will get xy then cos y by x dx. Understood? Okay, now multiply this term with this, so it will be x into x, it will be x square into cos of y by x, right? Dy will be equal to, see what is here, this term into this term, so what will you get? You will get xy sin y by x dy minus, when you multiply this with this, then what will you get? You will get y square sin y by x, right? So this is our new expression, right? So see, so what can we do now? So students, now take all the dx and all the dy to one side, right? So see y sin x, sorry, y square sin y by x and this dx. Okay, so now we will separate them. Okay, so take all the dy to one side, right? So see, what is it? Dx. So write it xy cos y by x dx. When we take this term to left hand side, it will be plus, so it will be y square sin y by x dx, right? And it will be equal to this term, so write it xy sin y by x dy, right? Now take this term to this side, so what it will be? It will be, here is plus, so it will be minus, and write the remaining term x square cos y by x dy, right? Now student, take the terms common. Okay, what we have to take common? See, here is dx, here is dx, here is dy, here is dy, so take it as a common, right? So see students, here also y is common, right? So write it y into, if you take y common from this, then what will we get? This one x cos y by x, right, plus y square, and we are taking y common, so it will be y sin y by x, right, bracket close, dx, right? We are doing nothing but just the simple calculations, right? Just a simple simplification. Okay, we are taking dx as common. Similarly, we can take here x as common, so take it x into y sin y by x, right, minus, here is x square and we are taking x as common, so it will be x cos y by x and dy is my common, right? So till now I think everything is clear, and if not, then please stop here and check all the steps. Okay, so see, now what can we do? So students, see, can we take this dx to this side? Yes, so do it. Y into x cos y by x, right, plus y sin y by x. Sorry, we are taking dx as common, right? So it will be equal to, take this term, so it will be x into y sin y by x minus x cos y by x, right? And here dy is my common, right? And see, we are taking this dx to this side, so it will be by dx, right? Why? Because this is here, so when it will come, so it will be in the denominator. Okay, so see, what will we get? Which implies, see students, now take this term to this side, right? So what will we get? We will get this one. See, here is y. Now I am going to write this y to this side. Okay, just to match our this expression, so that you will be able to understand it easily, right? Here y is my common, and if you take this term to this side, it will be minus, right? Now we will write this x to this side. Okay, so write it, y by x minus x cos y by x. X is my common, so x, and then dy by dx, right? And see, what will be equal to, what is remaining in the right hand side? Nothing, means 0, right? So students, see, what is this? X cos y by x, x cos y by x. Let me change the color. X cos y by x, this one plus this one, yeah, matched. Y common, minus minus common. Okay, this one, this one, this one, this one, this one, yeah. See, finally we get it. Okay, so students, see, this is nothing but the same thing, right? Here they are just skipping few steps, right? And we are getting this one. Okay, so now we will solve this one. Okay, so that we will get the solution of this one. Okay, so we will do the solution of this problem in the next page, right, by continuing from this expression. So see, students, how can we solve it? So as we know that whenever we have to solve a homogeneous differential equation, at first we have to write the equation in the form dy by dx equal to something, right? And then we proceed further, right? So see, what is this side? See, we will take this term to this side, right? So see, it will be minus y sin y by x minus x cos y by x, where x is my common, and it will be dy dx equal to, see, when this term will move to this side, then it will be minus x cos y by x plus y sin y by x, y common. So this is our equation, right? And see, minus minus, so it will be cancelled out. Yes, now what can we do? We have to make the equation in this form, right? So we will take all of these thing to right hand side. So do it. So what will be remaining here? It will be dy by dx, and it will be equal to x cos y by x plus y sin y by x, and y is common, right? By, see, what is here? Here is y sin of y by x minus x cos of y by x and x, right? So this is our new equation. So students, now what we have to do? So as usual, we will let y equal to vx, right, and let it be equation 1. And students, see, here is y by x, right, here is y by x, here is y by x, and here is y by x, right? So for our simplification, we can replace this y by x with v, right? Why? Because from this equation we will get v equal to y by x, right, and let it be equation 1. Okay, now we have to find this term, right? So see, we will differentiate equation 1 for this, right? So by differentiating 1 with respect to x, we get, what will we get? If you differentiate, then it will be dy by dx, and it will be equal to v plus, if we differentiate, then what will you get? X will be as constant, okay, and it will be dv by dx. Let it be equation 3, right? Till now I think everything is clear, okay? And still, if you have any doubt, then ask your doubt in the comment section, right? Students, see, here I am going to change something so that our calculation will be more easier, right? So see students, if you take x as common from this expression, right, then what will you get? See, let me change the color. If you take this x as common, right, then here you will get y by x, okay, here you will get y by x, right? And similarly, if you take x common from this expression, then you will get y by x from this side, okay? So we can replace this y by x with v, right, and so that our calculation will be more easier, right? So let's try it. So taking x as common, what will you get? You will get, let me change the color again, white, color of peace. So it will be cos, instead of, write it, y by x, right, plus if you take x as common, then it will be y by x, and it will be sine y by x. X is common, so it will be xy. Similarly, in the denominator, it will be, if you take x as common, then here it will be y by x, right, and it will be sine y by x minus, x is common, so it will be cos y by x, right, and here x square, right? And students, see, this x, here is x and here is x square, so cancel it. So it will imply that dy by dx is equal to cos yx plus y by x sine y by x, right, and here it will be y. Why? Because here is x and here is x square, so we are cancelling 1x, right? So here will be y by x sine y by x minus cos y by x, right, and here will be x, right? So students, see, x, right, and students, now see, take this term in the upside, okay? So what will you get? You will get this one, here is y, here is x, right, and now we are writing this y by x in this form, right? See, this is simple simplification, okay? I hope you are able to understand, right? So students, now write, finally we got our expression. So write, by using 2 and 3 in, let it be equation A, right, A, we get, what we get? See, dy by dx, it will be this one. So let me write in the next page, right? See, dy by dx, so we can write this one, v plus x dv dx, right? Sorry, it will be v plus x dv dx will be equal to, see, instead of yx we will write v, right? So cos v, it will be cos v, what is then, plus y by x, so it will be v plus v sin v plus v sin v, right? Bracket, what is outside, y by x, so again 1v, right? So write v by, what is there, there is y by x means v sin v minus cos v, v sin v minus cos v, v sin v minus cos v. So this is our new expression, right? So can we simplify it more? So yes, we can simplify. How? Take this v to this side, right? And then see what happens. It will be x dv upon dx will be equal to v cos v, take this v to inside, plus v square sin v, right? Y v sin v minus cos v, and this v will be here minus v, right? And it will imply x into dv by dx, it will be equal to, take the LCM, so the LCM will be sin v minus cos v, right? So it will be v cos v plus v square sin v, right? And what it will be, multiply this term with v, so it will be minus v square sin v, minus minus will be plus, so it will be plus v cos v. Simple calculation, right? And it will imply dv by dx, it will be, see, this term and this term will be cancelled, sin v, right? So what is the remaining one, v cos v plus v cos v, so it will be 2v cos v, right, by v sin v minus cos v, right? So students, this is our new expression, right? And see, yeah, now we can separate the variables, right? So take all the v to one side and x to another side. Then what will you get? You will get, see, here is my dv, okay. See, if you take this term to this side, then it will be reciprocal, so it will be v sin v minus cos v by 2v cos v, right? And dv, it will be equal to, if you take this term to this side, then it will be dx by x, right, as usual. So it is equal to dx by x, right? Now simplify more, so it will be v sin v by 2v cos v, right, minus cos v by 2v cos v dv, right? This is my dv, right? So it will be equal to dx by x, right? Now see, again the color of piece, it will imply, see, sin v by cos v, right? So it is tan v, write it, tan v, right? What is outside? 1 by 2, right? So it will be 1 by 2 tan v, right? dv minus, what is here? 1 by 2, and v is my in the denominator, right? So it will be 1 by 2v dv, right? And it will be equal to this term, so this is dx by x. Now see, yeah, now we can integrate, right? So see, by integrating, both side with respect to x, we get what we get. We will get this expression that see, 1 by 2 will be outside, integration tan v dv, right, minus 1 by 2 will be outside because this is a constant, 1 by v dv, it will be equal to integration dx by x. Students, see, you know the integration of 1 by v dv, right? It will be log v, and integration of this will be log x, right? But what about this one? So students, don't worry, this is nothing but just the standard integration, right? See, this is the standard integration. What it is, that 10x dx is equal to this one and this one, right? So you can proceed by using any one of them, right? And students, I am going to take this one. Okay, so see, we can write, what we can write, that integration of dx, right, it is equal to 1 by 2 integration of 10v dv minus 1 by 2 integration 1 by v dv, right? So students, see, here is 1 by 2, here is 1 by 2, right? So now we are taking 1 by 2 common from this side, right? So what will we get? We will get integration dx by x is equal to 1 by 2h common, so the remaining will be 10v dv minus integration 1 by v dv, right? And student, for our simplification, take this 1 by 2 to left hand side, so it will be 2 integration dx by x is equal to, it will be integration 10v dv minus integration 1 by v dv, right? So students, now we can integrate it. Okay, so it will imply that 2 log x, right, will be equal to, what is the integration of 10? So this is the integration of 10, right, log cos v minus, what is the integration of it? So it is log v plus integrating constant log c, right? So right here that where log c is the arbitrary integrating constant, right? So students, now we have to do just the simple simplifications. Okay, so see, we can write these two in the power of x, right, by using the log property. What is the log property? That if a log x, right, so you can write it as log of x to the power a, right, where a is my constant. So see, instead of a, here is 2, so we can write it like it will imply log x square, and it will be equal to minus log cos v minus log v, right? So write it minus log cos v minus log v plus log c, right? So student, this is our new expression, right? Log x square is equal to, see, take here minus common, so what will you get? You will get log of cos v plus log of v plus log of c. Clear? I hope I am able to make you clear everything, right? If not, if you have any difficulty, any doubt, any question, then please comment your doubt. I will make you a proper reply. Okay, so what it will be? It will be minus log, by using the logarithmic property, what will you get? You will get that this is equal to v cos v. How we are getting? C. Here basically we are using the property of log. What is the property? That log a plus log b is equal to log of ab. We are using this property, right? And there is another property, that log a minus log b is equal to log a by b, right? So these are standard results of logarithmic functions, right? So we are going to use it here. We have used this one here. Okay, so see, now we will rearrange it again. So it will imply log of x square is equal to, write this log c, okay, minus this term, so minus log v cos v, right? And again it will imply log x square is equal to c. We will use this property. So log, what it was a by b, right? So here it will be c by this one, right? v cos v. See, I hope you understand, okay? If not, then comment section is only for you. Now see, this side log, so it will be cancelled. So cancel it. Let me change the colors so that it will looks beautiful. So it will be equal to x square is equal to c by v cos v, right? And it will imply, take this to this side, x square v cos v equal to c, right? And students, see, what is v? So see, from equation 2, v is equal to y by x, right? So use it. v is equal to y by x. So instead of v, we will write y by x, right? This is cos y by x is equal to c, right? And it will imply that, see, x square and here is x, so it will be xy cos y by x is equal to c, right? Where c is arbitrary integrating constant, okay? And this is our answer, okay? So this is the solution of this problem, okay? And students, see, if you want, then you can solve it by using this one, okay? And student, one more thing, that see, in this case what I have done, that this was our equation, right? And what we did, we took this to left side and this to right side, right? Then we have added that integrating function log c, see this log c in the right hand side, right? We have added it to the right hand side, okay? But you can do like that, even you want, then you can add this log c to this side also, right? What does it mean? You can try that, integrate this side, then integrate, when you integrate, then you will get here log x plus log c, right? You can try like that also. The answer may be changed, means the expression of the answer may be changed, but that will also be correct, right? So it will remain homework for you. Do it yourself, right? At first try to do by using this one, right? Then try to do by taking the logarithmic, by taking the integrating constant to this side, okay, with this term, right? So these two will be your homework. Do it yourself, and if you have any difficulty, then comment, okay? So see, so finally, thank you for watching the lecture, and I have written a very beautiful line for you, that mathematics is the most beautiful and most powerful creation of the human spirit, by a great mathematician, Stephen Banach, right? And with this line, I want to end this lecture. Thank you.